Okay, let's just see how we can work out 6 problems you haven't seen in a while. So here we go. First off, let's draw the graph. I got negative. It's a square. So I know that A, it's been shifted up 5. It's been shifted right 3. And it's been flipped over the x-axis. Okay. Now I'm going to talk about how to draw that. So I'm looking at the original one, which would look something like this. And I'm going to show how it's been changed, transformed, if you will, to its new location. Sorry, my pens are not super accurate. So it's been shifted up 5 and right 3. So that's 1, 2, 3, 4, 5, 1, 2, 3. So that's its new vertex location. Can I get it to draw? There we go. Vertex location. But then it's been shifted over, flipped it over the x-axis, which is upside down. So right there, right there. 4. It's not stretched at all. There we go. 2, 3, 4, 5. 2, 3, 4, 5. So that's essentially what the new one looks like there now. You know, if you didn't have or if you want to just like dash the original, you could do something like that just to show the parent function on there. But I did ask you guys to add one more thing. I said, tell me what the xy becomes. So the xy here becomes the x is just going to have 3 added to it, but the y is going to become negative and then plus 5. So negative y plus 5. Yeah, and that matches up because if I take this y right here, it's a 1, then I turn it to negative 1, and then I add 5 to it and shift it over 3, it goes right to there. So that works. Okay, there we go. And you're going to do that for each one of these. Noticing that the second one's the only one you have to worry about. We're not going to use that negative on the x. So that one would literally just be x minus 2 and at y plus 2. And the shifts here would be up, I'm sorry, plus 2. It should be plus 3. The shifts would be up 3 and left 2. All right, so you're going to continue on and do the rest of these. They're all pretty much similar to this. What's up?
I thought that was homework to do that.
Right, they were just asking about the homework.
Oh.
It should be, that's what it is. Was there, so there was another question on here that you guys wanted to see, one that I didn't touch on yet. Have I met all the questions you guys have? Yes.
Can you write the xy to like the equation for
number 3? So yeah, it would be x minus 3 and y minus 2. Excuse me. Here, this one would be x plus 2 and then negative y plus 3.
So on number 3, there's no absolute value around the line?
No, don't. When we're doing transformations, the function, the basic function itself doesn't really play into it at all. So don't worry about things being squared or cubed or square rooted or cube rooted or absolute valued. It doesn't affect the transformation. Transformation, if it's a plus 3 on the inside, it's still a plus 3 on the graph. It does not get absolute valued or square rooted or anything like that. It's just a plus 3 to the plus 3. Any other questions on the homework, the 6 problems? Yes.
So any negative in front of the x and whatever the x did happen to the x, any negative in front of that radical or absolute positive value, that would be part of the y.
Right. It affects the y. Not
That would make it negative y.
That would make it negative y.
Okay.
So yeah, it's kind of you can almost treat it as it's separate. Like if this one had not had a negative in front of
It would
it,
just be y plus
it would still be y plus 5, right?
Yeah.
So it's treated separately than the 5. Very good? Okay, let's move on to today's work then. Unless somebody had another one they want to know the answer to, or anything, yes?
So on number 4, would it be flipped over, reflected over there?
Yes, it would. Let me grab my scrolly majig so I can stop walking. Come, let go. There. Boy, that thing had a hold of it. Something got a hold on me. Y'all don't know that. The day the squirrel went berserk in the first self-righteous church.
I know that one.
In that sleepy little town of Pascagoula.
Ray Charles?
Rex Ray Stevens.
Yeah.
Yep. All right, so this one is going to go up 3, right 2, and it's going to get flipped over the x-axis. So the normal graph would look like this. Well, I ain't sitting up with the dead no more. I don't know about you. Okay. This ain't the dead can't hurt you because they already left what they left. Can sure make you hurt yourself. I ain't sitting up with the dead no more since the dead started sitting up too. All right, so this is up 3 and right 2. Yeah, his old grandpappy Fred or Uncle Fred or something like that. He was so bent over with arthritis that when they had him in the coffin, they had to strap him down to get him to lay out straight, and the straps broke in the middle of the wake. It's the premise of the funny song. Everybody jumps up and heads up. What?
Wait, it wasn't an actual squirrel?
Huh?
It wasn't.
It was on an album I had with Mississippi Squirrel. This was a different song called "Sitting Up with the Dead" or something like that.
Aren't those continued?
What's that?
It's a cube root, so isn't there more?
Oh, I'm sorry. Thank you. I didn't even pay attention to the keyboard. So yeah, actually, I completely graphed it wrong because that should have been over 8. Thank you for catching me, Ms. Downham. So this should have been all the way over to 2, 4, 6, 8. So really to there. There you go. And then that should have been 1, 1. And then, yeah, I was too busy having fun singing. There we go. So now the same thing's going to happen here. You're just going to extend this out. It's still upside down. It's still, I didn't count that out, but just for argument's sake, it's somewhere about there. And then, somewhere about there. I'm just kind of penciling it in, but that's roughly your picture right there. And finally, I think we already did the points, right? It was just x plus 2. Negative y plus 3. All right. So much for your homework. Let's move on. We are on page 13 next, I believe it was. Scroll past the piecewise functions and the absolute value functions. And we are on page 13, computation. I'm sorry, involving function notation. Now, yesterday we kind of talked about this with the first one. what were the three things we know from the statement that f of negative 4 equals 2?
X is negative 4.
Okay, somebody else? Nathan?
Y is 2.
Y is 2. And
It's an f of x function.
right, so if I had 2 or 3 functions, I would know which function to go to. I'd go to the f function and my x value. So it's f function with an x value negative 4 and a y value 2. If you will write f of x equals y, 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 right? If you will write it a lot, you will start getting it drilled in, hey, every time I see this, I know what the x is, I know what the y is, and I know which equation it came from, which graph, right? Because as we get more advanced, we'll start having more graphs and more functions operating at the same time. Okay, so f of x equals y, f of negative 4 equals 2. I'm going to take that and plug that in. I'm going to get to f, and we did this yesterday, equals negative 2 times negative 4 plus 3, 20 squared plus 4. Okay, and then do a little quick math. Negative 4 plus 3 is negative 1. When I square it, it's going to be 1. So this is negative 2 plus 4, which equals 2. And that's where I got my answer. All right, so plug in f of negative 1. Negative 2 times negative 1 plus 3 squared plus 4. And I'm going to get negative 2 times 2 squared plus 4. So that's going to be negative 8 plus 4, which is just negative 4, right? So f of negative 1 is equal to negative 4, and then f of 0. Now it feels like the heat's on. Thing's got a mind of its own. And then f of 0, f of 0 is equal to negative 2 times 0 plus 3 squared, so just 3 squared plus 4, that's negative 18 plus 4, that's going to be equal to negative 14. Okay, with your partner, I want to ask you the question. When you found the value of f of negative 4, and the x is negative 4, then what did the result of finding f of negative 4 represent on a graph? Like on a graph, you found that the result of f of negative 4 was 2. What is that on a graph? Talk with your partner, decide, and raise your hands when you guys think you know what it means on a graph.
What was that question again?
It's right there.
What does the 2 represent?
I ask you the question right underneath the boxes.
Yes. It would.
Graphically, it means so. So,
Okay, who wants to tell us what they think? All right, Zach, what you got?
So the x value is negative 4, and you know that. So if the x value is negative 4, then the y value is 2. And those are the points.
Basically just the y value of the point, right? I mean, you could literally just write the y value. But yeah, it's going to be the point, negative 4, comma 2 is a point on f of x. And the y value, it's almost redundant to say this, right? It's already written there, is 2, right? So all I want you to note is the connection between the points in the graph, the equations in the graph, and how whenever you find something like f of 0, it's actually a graph point that you can look at. I'm not changing it, I just want to know. See, now it says 69. I swear I've never changed it.
Are they changing it?
Well, I think we changed it yesterday in the teacher meeting. No, we had one yesterday. Maybe it was like that for 2 days. Okay, let's move on. Everybody got this copied down?
Yes.
Yes.
Where'd you get the 2 from?
Right here. F negative 4 is equal to
Oh.
2.
Gotcha.
So negative 4 gives me 2. We plugged in a negative 4, we got back a y value of 2. Okay. Woo. That's a mess. The graph is pictured to the right. Now think back to those 3 points. I can't show them up here because I have to delete them every time, but you've got them, right? Take a look at this graph and with your partner, try to make sense of what those f of negative 4 equals 2 and so on and so forth. Do they jive with what you're seeing in this graph? Take 1 minute, raise your hand when you guys have got it solved or you come to a stopping point.
What's some of the points line up? Negative 4.
Why don't you find that out by looking
Negative 1, negative 4.
Any groups got theirs done?
They all are,
Yeah.
all the points are in there.
negative 4, comma 2, negative 1, comma negative 4, and 0, comma negative 14.
So you get
I need to
no,
unlock
that's
this
what
one.
it's 2.
He's like, are you going to tutoring? Are you going to or no?
All right, let's start up front. Lexi, what you guys got?
So we got it did work.
How do you know?
Well, so it's the coordinates negative 1, comma negative 4.
Absolutely. Negative 1 gave us negative 4, and that's a coordinate in your graph, right? So that's a coordinate. The other one was negative 4, comma 2, right?
I don't think f negative 0 is, or f 0 is, you can't technically say that it's on there because you can't see it, you don't know if it actually.
That's right.
We don't have arrows.
But if we follow this pattern, do we think that it's going to happen?
Yeah.
Does it look likely that this could go down here and hit into 14?
Yeah.
So if we plug in a number to our f of x and we get back a value, we have created a coordinate, negative 1, negative 4, that is on the graph. Negative 4, negative 2. So that's what we're looking at, guys. I want you guys to relate. I don't want f of 2 equals 3 to be something that you only do when you see an equation. I want you to see f of 2 equals 3 and then relate that to a graph. This book right here, and whenever I do pre-calculus, I'm big about 3 terms. Graphically, numerically, and analytically. What do those 3 things mean? Well, how does it appear in a
Graph.
How does it appear in a table of numbers, right? You guys have done that for a long time. What's the pattern going on in the table, right? And then finally, analytically means basically how does it show up in the equations? So graphically, numerically, and analytically. And I want those to just be interchangeable. I want, in your mind, not to see a table problem and just put that as a table problem, and a graph problem is a graph problem, and a function problem is a function problem. I want them all 3 to be interchangeable tools. It's like you can see it in different modes so that you get a different feel for the problem based on, if I see it in a graph, it's going to look one way. If I see it in a table, it looks a little bit different. If I see it in a function, it looks a little bit different, right? So you want to be able to read all 3 of them and relate them together. Okay, so yeah, we're going to say yes. they showed up as points on f of x. All right. Now, what about this? The graph of f of x has 2 zeros in it, right? What does the, in the term, in the idea right now, I want you to define or talk about what you think they mean by zeros in a graph. So looking at this graph, if I told you it has 2 zeros, what do you think it means by the term zeros? And your partners, let's go.
I remember that 0 for this, I think it equals 1. Or something. Oh wait, no, I'm thinking about powers. Never mind.
Two values. There's two x values that could be
Alright, so,
y values.
What do you think?
I thought it meant it passed. But that seems too simple for this. So.
okay, so that, okay. Define that.
All right, Alex, Magnuson. What you guys talk about with the zeros? What were you guys thinking zero-wise? Because I know we haven't had algebra 2, but we can try to figure this out ourselves. So what do you think about the graph has zeros?
We thought that there's going to be two zeros where x equals 0 and then there's a number, and then y equals 0 and there's a number.
Okay, so an x-intercept could be a 0, a y-intercept could be a 0. So when an x is 0, that's a 0. When a y is 0, that's 0. If they were both zeros, that could be a 0, right? Will this graph have a place where an x is equal to 0?
Yeah, it will
Is it on the screen right now?
Yes. Where x is equal to 0? No. I don't know which one you're talking about. Oh, x. I don't know if you're talking about x equals 0 or y equals 0.
X equals 0. Is there an x equals 0 up there right now?
No.
Not right.
Now here's the terminology tricky thing. A y-intercept is when what is 0 in a y-intercept? Is the x 0 or the y 0 in a y-intercept?
X is 0.
So in a y-intercept, x is 0. So in an x-intercept,
Y.
right? So you got to get that, because that'll get stuck in your head, right? If you don't, I mean, if you think x-intercept x is 0, you're getting it messed up, right? So you gotta kind of play with that. So the question is, this one specifically says it has how many zeros?
2.
So now, do we have to change our definition? We said x-intercepts could be zeros, y-intercepts could be zeros. But they're using a very specific word 0, and they said there's 2 of them. They didn't say there's 1, they didn't say there's 3, they didn't say there's many. They said there's 2 zeros. So should we change our definition?
Yes.
What are the zeros?
When the x is 0 or y is 0. Sorry.
When the y is 0. We also call those?
X intercepts.
We also call those? 2 more words. I had you write them down a couple of times already at the beginning of the year. X-intercepts. Zeros. Something to do with trees.
What?
Roof.
Ball.
What was it? Somebody said it. Roots. Oh, Juan said it? My hearing's so bad now. I'm like, I'm the one that gets eaten by the tiger, by the way. So, as you get old and your hearing goes down, you know, your food and the rest of the tribe gets to run away. So, yeah, no, roots.
What?
evolution. That's how we evolved, right? Natural selection. The ones that get eaten, they don't get to move on. You don't have kids. No, luckily I was old enough to already have my kids, so my genes passed on. All right, so roots, zeros, x-intercepts. One more word, with an S.
Square.
Write them down, guys.
Squirrels.
We're going to say these quite a bit.
They're in trees.
Metric.
Write them down.
Solution.
I didn't say it did. I said roots had to do trees. Okay, roots, zeros, x-intercepts, and solutions. Has to do with science. Solvents, solutes, mixtures, colloids, solutions. All right, roots, zeros, x-intercepts, solutions. These are all words for
Zeros.
all names that mean the y equals 0. Now, do you think that they came up with 4 different names for the same item, if it's very unimportant?
Yes.
No.
Do you think that this might be something that gets used quite a bit? Can you think of a time when it's important to know the 0? The y value equals 0.
When you're trying to find out if it's a quintic or
Yeah,
When
because
you're
there's
trying to
multiple
find out
times
if
it
it's
passes
0
through.
or just
Double
it's
shape.
Doing it.
you're jumping way
What's
in
the time when the y value equals 0 that's kind of important?
Oh,
when it's a
Y value.
constant.
Whenever it's B.
When you're what is it? I don't know.
Like in physics.
What?
When you are tossing a ball up, and where is 0?
The ground.
No idea.
Right.
The top.
Now we might call this 0 because my hand is the starting point and the finishing point, right? But basically it's the time that I launch it and it comes back, right? So this would be an example of where I'm wanting to find a root. I throw a ball up in the air at a certain calculated speed with a certain initial position, and I know that the gravity of Earth, the force, is negative 9.8 meters per second, and I should be able to calculate how long it takes for that ball to hit the ground. When it hits the ground is the other end of that 0.
Can we calculate it?
Tell me how fast you want it to go and how high you want it to go, because I'll just use this equation.
100 miles an hour, 10 miles.
I don't think you go at 100
You guys
miles per
remember
hour.
we're recording this also.
Oh, yeah.
Well, you could
That's okay.
baseball pitch.
It's still class.
Let's go watch this.
YouTube
Maybe before
Position final is equal to this is the speed of gravity divided by 2. It's negative 1/2 at squared, which a is your acceleration. In the case of Earth and balls going up and down, we're talking about gravity is our accelerating force. So negative 9.8 times divided by 2 times t squared plus v naught, which represents our starting velocity, how fast the ball leaves my hand, right? And p naught is our starting height. Now, if I start at 0, come back to 0, then I could leave 0 there for p naught. But if I start by throwing it off, if I'm that monkey game throwing a banana, and I start standing on top of a building, and it's 300 feet off the ground, then I'm going to need that to know, it's 300. This is starting position is 300. So pick any number that you want. How fast do you want the ball to be flying?
300.
300 feet per second?
Yeah.
Woo!
300.
Okay, so V naught is 300 feet per second.
Man, the monkey's got an arm.
How high were you off the ground when you threw it?
Not me.
On the Empire State Building.
Winston.
You're in space.
1,000. Now, by the way, we're doing meters per second, so really 300 feet per second is roughly 100 meters per second, and 1,000 feet is roughly
A lot.
we're just going to cut it to 300. It's really a lot more now. But so we're at 300 meters up, and we're throwing it at 100 meters per second. And then we're going to plug this into your calculator at negative 9.8. Well, this is actually divided by 2 is negative 4.9 t squared plus 100t plus 300 equals 0. I'm going to put this in the Pythagorean, or no, not Pythagorean's theorem, good lord. The quadratic formula. I'm going to put this in the quadratic formula with a calculator, and it's going to be x is equal, or t is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. And I'm going to plug all that in, and I should get the answer. And if you did this, square root of b squared minus 4ac all over 2 times negative 4.9.
It's a very
It's
big
going to cancel out the positives, so I don't need to worry about the minus. Just do the plus. It should give us a value. Plug it in. You'll find how long it takes us before this hits the ground again.
Is this in seconds?
What?
Is this in seconds? How long?
So it's
It should be in seconds because we're going in meters per second.
So it's negative 100 plus.
Negative 100 plus the square root of 100 squared minus 4 times negative 4.9 times 300.
100 plus the square root of.
Yeah, this is position final. This is when our position final is 0. We want our position final to be 0. Right?
That means you're throwing it 300 feet in the air.
No, we're starting at 300 meters up. We're standing on top of the building 300 meters tall. Throwing it at 100 meters per second really fast. It's going to go really high before we're done. Somebody got a calculator, put that in there, find out how long it took us. Come on.
Come on, Nathan. Your Casio can't keep up.
That's pretty good.
It's negative. Oh gosh, I screwed this up somehow. Beautiful. I got a negative number, so that's I got negative 2.6546808179.
All right. I'll let you guys finish calculating this and tell me here in a minute. Let's move on. So if one of you guys will calculate that for me, make sure that you've got all your parentheses in the right places, guys. Just put everything in with the parentheses if you have to. What is it? Oh, okay, well then actually try the minus one. Change that to minus then. Because there will be a negative number because if this is showing where 0 happens, and if you're standing on a building 300 meters tall, then 0 happened before, and then it came up to me and it continued on, right?
So
It's like,
I had a positive number and then I divided by 2 times negative 4.9 and then it got negative.
It's still negative.
what is it? Negative 87 or, did I forget a,
Negative.
So it was positive and then I divided by negative 2 times negative. And then I divided by 2 times negative 4.9. And then
Now I'm not that bad.
let me see your calculator. Make sure you're putting it in right. No, because you didn't divide the whole thing. You divided here's what you did. Right there. You got to put a parentheses around the entire top. So yeah, hit second insert, put a parentheses there, and go all the way to the beginning and put an insert there. All right, guys. Guys, let's go while they're getting that figured out. Let's move on to this. So it says that the graph clearly crosses between. Did you find it?
I think so, yeah. One calculator says 23.06.
So 23 seconds is how long it's going to take before it comes back down and hits the ground. That seems about right because you're throwing it so fast, it's going to go really high in the sky before it comes back down.
How
I
high
mean,
is it?
You got to figure 300 meters. You're already standing on something that's 3 football fields tall, and then you're throwing it 100 meters per second, which means it goes 1 football field in a second. So I mean, it's going to go really high. If you want to find out what the height is, no, that's actually a whole chapter. We're going to do a whole chapter on this guy. So,
Yeah, I still got a negative. Still got
Oh, yes.
Yes. You got it now? Yeah.
I still got
That's all related to putting parentheses and stuff. You got to put the parentheses around. Like for instance, you need to put the parentheses around the entire top
Yeah, I did. And
so
then,
that it doesn't go in. He got it now. So I'm thinking it's got to be something related to parentheses. Well, let's move on, guys. We got to get to this. So here it says that if you look at the graph between the points -4, I'm gonna clear all of this so it's off of our page. Between the points -4 and -1, okay, in the graph we can see that it crosses the x-axis. That's the graphical. Now let's go to the numerical. What's the numerical proof? Knowing that we had f of -4 equals 2 and f of -1 equals -4, you should be able to make a statement from the numerical proof without having the graph in front of you. Because I'm going to ask you to do that. I'm going to give you 2 points like this and say, can you prove, given these 2 points, that it crosses the x-axis between those 2 points? What's another word for crossing the x-axis? I guess that'd be our 5th word. Y, or sorry, I mean x-intercepts. What's another word? Zeros, solutions, roots. Let's say them together. We've got roots, solutions, zeros, x-intercepts. Crosses the x-axis. That all means the same thing. Annie?
I was gonna give numerical proof for that.
Numerical proof, tell us.
One's a negative and one's a positive. One of the y values is negative, and one of the y values is positive. So therefore, it has to cross 0 if those 2 points are connected in any way, shape, or form.
So if it's a continuous graph, right, it doesn't get, you don't pick up your pen. If it's continuous, Annie says that if it goes from negative to positive and it's continuous in between, then it had to cross 0. Does everybody agree with that? So let me give you an example in physics. If you've got a car and it can only drive on a straight road, and it can only go in forward and reverse, and it doesn't have the ability to steer. So it's locked, it's a train, right? It's like a train. It's locked on one path. If that car is going forward and you look away, and then when you look back, it's going backwards. It went from a positive speed to a negative speed. Can you be guaranteed that it had to stop somewhere in between?
Yes, because it crossed 0.
It had to wait for a second.
It can't go.
It can't instantaneously.
Yeah, it can't just like jump from.
Unless there was a loop
Yeah,
that
it
went
just
back
jumps
into the negative and then it just went around the
Like I said, it can't go in any sort of curve. It has no steering wheel. It can only go in a straight line forward and backwards.
It crosses 0.
So if it's a train, so it's a train, but what if the track?
That's what I said. It's on a straight line. It's got to go straight line forward, straight line backwards. Here's another example. If I throw a ball at the wall and it bounces back at me. It just changed from a positive speed to a negative speed relative to me, right? Did it have to be stopped? Did it have to have a speed of 0 at some point in that scenario?
It had potential energy at some point.
Right. It went from kinetic energy. As it hit the wall, it smashed, building up potential energy. Eventually, it's like a spring, but it's stopped. For, a nanosecond, but it's stopped, right? It's completely squished and stopped its forward motion, and then it unleashes the potential built-up energy in that spring-type, compression into a backwards motion. What's it called? Elastic, thank you. Elastic potential energy. So it takes that potential energy from being from kinetic energy, stops speed, and then turns it into kinetic energy in the other direction using that elastic force. Okay. So yes, that is our answer. That since f of x changes from positive to negative, it must cross 0. All right, since it changes from positive to negative, it must cross 0. Yes.
Can I use restroom?
Absolutely. Guys, you know what? I don't have anybody that I ever worry about using the restroom too much in this class. In this class, you are welcome to go. Just kind of get my attention, and not you guys can always go. All right, let's move on to the next section. Now that's going to be very important because we're going to have points on a table later on, and we're going to talk about if I've got points on a table, how can I be sure that I know where the roots are, right? And you could look at it and say, oh, hey, y value is positive, y value is negative, something had to happen in between there, right? Okay. Ooh, here's another question for you. Did it have to go from positive to negative? To stop. Did it have to go from positive to negative to hit 0?
Yeah.
It goes from positive speed to 0 to positive speed. What would that look like on a graph? A parabola. Comes down and touches. That's a whole section we'll do. Not for this class. Not for this class.
Okay.
There's also a chance it could go backwards, but that's just
Right. You could do. There's actually 3 of them we're going to look at. We're going to look at a root with multiplicity 1, 2, and 3. A 1 looks like a straight line, like a normal crossing through the line, and the 2 is the parabola, and the 3 is actually what we call a jog. It kind of goes sideways for a moment. That's a cubic. Okay, guys, we're gonna quickly look at this one. You know what? No, let's just skip it. It's not necessary for the work. We'll do the work without it. So here we go. Starting on the next page, find the value of g of negative 6, g of 1. So let's start this by taking and doing what we've already learned. G of negative 6, so if I could get Lulu, could you guys find me g of negative 6? And Annie, could you guys find me g of 1, please? Now, I want the rest of you guys to try to work it out and see if you guys can beat them. See if you guys can find the answer of g of negative 6 By the way, the equation is right here in case you missed that. G of x equals absolute value of x plus 2 minus 5, right? Raise your hand when you think you've got the answer for it. 1. Yeah, I think that you can get the answer for both of them in about 1/1000. Two, three, 4, 5. 6. Huh? The dice? It was just for me showing it. Now I've just enjoyed showing it up in here. 7, 8. All right. How far did you get in working out that equation before you realized you didn't have to?
I didn't realize that.
But yeah,
I never remembered that.
I didn't.
Well, I never had.
Yeah, because the graph.
Oh my god.
Did you see?
Yeah, stupid.
Graphically, numerically, analytically. Want to tie all three things together, right? We don't have to know the equation to be able to find this answer because we have the graph. Now, we want to check ourselves and use the equation anyway. So if you did the equation, I wanted you to, but I also wanted you to notice that you didn't have to. Right? So if I do that, I'm going to get what? G of negative 6 is equal to, that's going to be absolute value of negative 4 minus 5, right? And so that's going to be 4 minus 5, so G of negative 6 equals negative 1. But I didn't need to do that to get it because I have the picture over here. If I go to negative 6, what's the answer? Y equals negative 1. So now if we look at what is G of 1? Negative 2. We don't need to go and then plug it all in, right? So G of 1 equals negative 2. All right, good. Now, don't say it out loud. I don't want you guys to run it for everybody. Let everybody have their chance to work it out, mull it through. Find me the answer. So this is a little different. You guys remember back whenever you were doing your area. I know I reference this a lot of time, right? You were doing a rectangle, and they said, well, the length is 4 and the width is 5. Find the area of the rectangle, right? But then they came back the next day and said, well, if the area was 18 and the length was 6, what's the width, right? It's kind of working it backwards, isn't it?
Yeah.
Now I'm asking you to find what? Where is G of x equal to negative 4? So I'm not asking you to find the y, I'm asking you to find the x. Find the values of x. All right, when you find it, don't say it out loud. Please just raise your hand, let me know. 1. 2. 3, 4, 5, 6, 7, 8, 9. How long is it going to take before it sets in? How long is it going to take before you realize there's something different here?
Yeah.
When you see, you're like, oh,
Oh.
then raise your hand. Let me know. Okay, 3, 4, 5 of you. 6, 7.
Still working it out, but I already know what's different.
That's all I need. I just need you to know there's something different about this than the last couple of questions, right? Okay. Come on. What do you think?
Well, since we already know that the y is negative 4, all we have to do is go down the y line, and you see on the y there's a point negative 1 for x.
Put a different color. I don't know how to, there we go. Sometimes this thing doesn't pop up. You talking about like right there?
Yeah.
Is that right? Yeah, good. All right. Nathan?
But then twist ending, there's another point.
Oh.
There's the, right? Because values,
Oh.
right?
Wait,
There are more than one option for where the y value is for. Was it okay for a function to have one y that has two different x's? Can two different buttons perform the same action on the remote control?
Yes, I have an example.
What's that?
It's like some TV remotes have like an on button and an off button, and they both turn the thing off.
Okay. Well, I had an old flip phone that had three ways to turn it on and off. You could flip it open, or to answer a call is what I should say. There was a button that actually, a green button that answered the call, or there was another way to set it where the outside buttons would answer the call. It's okay to have multiple buttons that answer the call. Do you want the answer call button to also turn the volume up?
no.
Right. You don't want one button to do two things, but it's okay to have two buttons do one thing. This is still a function. It can have two different x values that give you the same y. You just can't have two different y values for the same x. All right. So now try it out for me. Now that you know, this is going to be, and I'm going to show you a couple of ways to write it. Anytime we have a list of values, you can use braces, and we're going to write -3, -1, right? For what values of x, you got -3, -1, or you could write x equals -3 or x equals -1. Finally, we could use our newfound function notation, and we could say g of -3 equals -4, or g of -1 equals -4. So I like to show you all the ways to write it, so because you might see it as different multiple choice options on different tests, right? I didn't write the ACT, Aspire, or the ACT, or the SAT, or the PSAT, or the NMSQT, or the ASVAB, or the ACTAP, or I didn't write any of them, right? But I know that they do all kinds of different formats, so I want to make sure that you guys are familiar with how you'll see the answer in different ways. All right, so now try to find me for what values of x does g of x equal 5. This is going to take a little bit of work. Find me the last question. This one doesn't just,
Give it to you.
give it to you. And if you're kind of struggling with a start, just remember, what does g of x mean? What does it stand for? Y. The y. So I'm really asking, where's the y value at? So look at that graph and say, it didn't go up to 5 on here. So yeah, now you're going to have to find it. Takes a little work. But if you use a pattern, you might be able to get it pretty quick. Some of you might want to challenge yourself and see if you can use the equation. Remember, to get rid of an absolute value, replace it with a plus once, and then replace it with a minus once. Like, you change it into a parentheses and do plus once and minus once.
I saw it on a previous page, and I had seen that right before we went into this, so I had that fresh in my mind, and I just went.
Yeah, solving an absolute value.
Mhm.
Yeah, that's what that previous page was. We actually did that a little bit earlier in the year, but I didn't want to mess with it. But you are going to need to be able to use that in some cases. So for instance, what I'm saying is you could solve this equation. 5 equals absolute value of x plus 2 minus 5. Right? And when you get down to getting ready to get rid of that absolute value, you're going to have to split it into two equations and say one of them's x plus and one of them's minus. And just put in parentheses where that absolute value was then.
I hope I got that right.
Why are you doing that?
Some of you might just be able to noodle it out from right here. You say, well, if 10 is equal to the absolute value of blank, right? Then say, well, what can I put in there for an x that would be a true statement? There's two answers, though. You gotta be careful.
Austin.
All right, who wants to tell us how they got their answers? Nathan?
Okay, so I didn't use the equation. What I did was I looked at the graph and I saw that going when the line was going left, the y equals 0 was x equals -7. So I basically just said -7 minus 5 because the slope was, I guess, -1 on that part.
So you were here and you said, if it's a slope of 1, it goes up 1 over 1. So that means if I wanted to go up 5, how far is it going over?
5.
Yeah, it's going to go up 1 over 1. So to go up 5, it would have to go up over 5. And what do you get?
-12.
I'll take it. Hey, would that work here? Would -12 plus 2 and then absolute value get you 10? Yes, it would. Okay. All right. Could you do that same pattern over here?
Yeah, that's what I did the same one. I just did 3 plus 5.
3 plus 5 gets you the 8. Good, good. All right. So sounds like somebody got me on Facebook Messenger. Let me show you how I would also solve this here, though, because you're going to want to know this tool. How do you get rid of? You know how to get rid of add. You know how to get rid of subtract, multiply, divide, squares and square roots, right? But how do you get rid of absolute values? You switch them out with the parentheses and a plus or minus. So that means, because you got to deal with the fact that it could have been a plus under absolute value, it could have been a minus under absolute value, right? So that's really going to be 10 equals, and this will be the plus version, or 10 equals minus. I think it thought my hand was too close. It didn't like it. Started drawing. So I do a plus version and a minus version, and I solve both of those. Here, if you subtract 2, what are you going to get? What's 10 minus 2? 8. Here, distribute the negative, and then subtract, then add 2, and then you're going to deal with the negative, and you'll get -12 over here. Yeah.
So you did the x in plus 2 with the positive and negative. What about that -5 up there? Did we just leave?
Oh, I had added it here. You guys.
Oh, it already happened. Okay.
Yeah. Like that. Okay. Let's take a look at. We've got one more section of these, and then it's. I believe after that, yep, it's just homework. Guys, before we get too far into it, I'll go ahead and let you know that you're going to scrub 13 and 14. You know, let me say this to you. I just did what 13 and 14 is. That's the solving an absolute value. If you want to try it, challenge. Guys, this is something I wouldn't ask of you as an Algebra 1 student, but if you want to try a challenge, do that with the replace. Solve it, replace the absolute value with a plus or minus. See if you can get to the answer. Okay? It's doable. It just requires you to be able to get rid of that absolute value. All right, so now go back to where we were. We've got one more practice.
So the homework is 1 through 12 and then 13 and 14 if you want.
Yeah, bonus for 13. I mean, it's extra hard challenge. Yeah. I mean, it's not really even that hard. It's just what I just now did. It's using the equation and solving it via the equation. All right. So h of -1. So how about we do Emma? You guys take h of -1. H of 10. Yeah, let's do you guys right here, Zach. And then h of x equals 1 in the back here, Lexi. H of x equals -3. Austin, I'll give you breaks since your partner's not in right now. So Lexi, Puckett, you guys take h of x equals -3. Now this one's not as nice, right? H of -1 ain't on the picture, neither is h of 10. That last one, you can just pull them right out. This one, you're going to have to use the equations. Give me a decimal rounded to 2 places.
Oh, decimal?
When you've got yours, come on up here and write it up for us.
Negative.
Only what's wrong though today.
Absolutely.
So it's for what value of x is hx.
That's why I was telling you.
The only thing I would ask, Alex, is that you put h of -1 equals, just as a more kind of complete. Somebody should be able to read that and knows what it means.
Wait, so x oh, I thought that means
Anybody else got theirs? The other 3 should be nice and easy.
I know.
Oh wait, yes I do. Well, I know I do.
okay, get it, Winston. Okay,
Also, I'm fine with if you guys ever go to the restroom and you don't want to interrupt people when you come back. You're welcome to kick that little stopper in there. I usually close the door whenever we're not using it, just because, well, A, security. B, it saves my throat. You'd be surprised the amount of volume you have to speak with in an open door, versus a closed door. You lose a lot of your volume out through the hallway. And if everything everybody can hear down the hall is volume that's not kept inside this room. All right, come on. Where's h of 10? Where's h of x equals 1? H of x equals -3. This should be kind of easy.
What about 8 to 10?
I don't know it.
Oh, I don't remember how to do it.
Because I can do 8 to 10.
I got one answer.
Wait, no, I didn't. I got one.
showing anything. That's all right. Please do h of what? Or x equals -5. Start with x equals -5 right there. Just put x equals. And then I want you to also write h of -5 equals 1. You're just practicing writing in different points. There you go. And h of x equals -3. Was that Lexi? Cooper? So we're asking where on the graph is the y value -3? What's the x value that gets a y value -3? Big day today in news, guys. I don't know if any of y'all are Ridgeback fans, but we did get Dave hired a coach. You got Chad Morris. I'm not sure if I like it or not, but he'll be exciting as far as the spread offense and trying to score a lot of points.
Because
He's doing
he
bad.
has
And just consistently not getting better. We expect a lot. We pour a lot of money into the team here. So.
X equals 3.
Yeah, come write it up there for me. X equals 3, and then put h of 3 equals -3. So make sure you're practicing writing it in multiple ways, guys, because you're going to want to be familiar with those as you see them written. If I give you h of 3 equals -3, or if I give you x equals 3, right? X equals 3, y equals. So you want h of 3, x is 3, right? And what is your y value? Right there. It's on the problem.
-3.
-3.
So negative goes here.
Yeah, put a negative in front of that 3. There you go. H of 3 equals -3. I like this packet, honestly. This is actually a 700-page workbook that I normally just print the whole thing up at the beginning of the year, and we would punch it, put it in a folder like a 3-hole binder or something, and go through it. And what I like about it is all the notes are built in and the homework's built in. I don't have you tear anything out. You just keep it and you can go through it through the entire year. It works really well with my pre-calc classes. And the tests are built exactly like the problems out of the book. Even to the point of, you've got, now the one thing that you might not like about it is you're going to do a lot more writing. There's going to be a lot more, like I normally would ask you guys to write out full sentences here. The function evaluated at x equals 3, stuff like that. Trying to write in more language kind of things. Yes.
So someone had put that h of 10 equals -5, where followed by find the value of h of 10.
I believe that is what they had here. H of 10 equals -5. Is that correct?
For that one.
Well, when you put 10 in, so you get 6 plus 3
Okay.
is 9, the square root of 9 is 3.
No. The plus 3 is on the outside of the square root.
Oh.
So you do 10 plus 6, because you're plugging a 10 in for x, right?
Oh, yeah.
So that'd be square root of 16, which would be 4. And that would be -8 plus 3, which is -5. Let's take a look at your homework for the night. Notice in numbers 1 through 4, they gave you the equation for p of x at the top. Now, okay, so here's the one. Let me go back and show you the one that we didn't work. because you're going to need it for 3 and 4. Not really. They gave you the graph right there. Yeah, I guess you guys can just use the graph right here. This graph is that graph for that picture up there. So when it gets to question 3 and 4, and it says what values of x does p of x equal 5 and p of x equal -4, you can just use the graph. I was going to show you how to use the equations, but we haven't got to quadratics yet, so I really didn't want to have to make you guys solve quadratics. But there you go. Just work out those problems, and then we'll talk about that open response tomorrow.
So did you say that 1 and 2 you could use the graph?
3 and 4. Yeah, I mean, all 4 of them you could use the graph. If I was you, I would suggest that you practice both ways, because on the quiz or the test that you take, there will be a specific, it will give you the graph or it will give you the equation, and it will be a non-calculator. Like, you won't be able to graph it on your calculator. If I give you the equation and say find p of 1, it means plug it in to the equation.
So do you want us to do the open response again?
The free response, we'll do that in class, but that's going to be practice, guys, because usually the test questions have a free response. Since we've got a few minutes, let's go ahead and practice it now. We can have it knocked out of the way, and I can go ahead and have it recorded on my recording. So, oh, never mind.
Oh
We
my
didn't
God.
do the piecewise functions. Let's just, for trial, let's try it out. Let me explain to you how a piecewise function works. Come on, click away.
Right here. In the back.
Okay. Let me write this 2 things down for you, and you will understand a piecewise function a lot better. What and where? The first part is the what. Now, there are mathematical words, like for instance, the second part are called the constraints of the equation, and the first part is called the pieces of the equation. But I just sum it up as the what and the where that needs to be done. So let's first look at the point. It says, what is p of -3? And let's decide. Now, what is the -3? Is that an x or a y? Because f of x equals y, right?
Yes.
So the -3 is the x value. The where is related to what kind of values? Look at it.
Under
Read it.
x value?
What does it say?
Integer.
3 is less than,
X.
which is less than 8, right? It's not saying 3 is less than y, is it? So it's related to the x values. This is the where on the x values. So which one of those lines, consider this like 3 pieces. It's an if-then. You guys ever done anything with if-thens? If this, then that. Then you go to the second one. If this, then that. And if this, then that, right? If it's red, then go left. If it's blue, go straight. And if it's yellow, take a right. If-thens. If this, then that. If this, then that. If this, then that. -3. Which if does it work with? Does -3 meet does it meet the requirements of the first where, the second where, or the third where? Is -3 between 3 and 8?
No.
Which one?
None of them.
None of them. Why?
Because you couldn't fit any of them in the at wheres. And it, or like, if I did, then it would be false.
Right, because they didn't include.
So it doesn't exist. That's not that hard, actually.
It's not hard. It is. This is more a foreign language than hard. It's a foreign language in the fact of you've never seen it and it's new, but it's not hard. Okay, let's try it up. Be a 4.
It's the third one.
Is it line 3?
Yes.
Now what do you do with it?
You plug it into that corresponding thing.
And you get what? Plug in 4 into which one?
The
The one to the left. Yeah, that one.
Yeah.
That it was just fine.
So what goes here?
Oh, it's on the last one, right?
4.
minus 5 to the second power. Yeah.
It's not as hard as it looks, right? Piecewise functions. It just wasn't on my. It was not on my agenda to teach you guys. I thought since I had a few extra minutes here, it'd be an interesting piece for you guys. It's not going to be.
But this isn't our homework tonight.
No, this was something we were going to do in class anyways. I just figured rather than do it tomorrow, might as well knock it out here. This next question is pretty fun too. It's like, remember all the parent functions?
Yeah.
Okay, now if you guys will scroll back, flip back to the section that talks about piecewise real quick. If you look back at the section that talks about piecewise, and there's a little picture where they show you, down at the bottom. See how they show you the scissors and stuff? So if you can imagine it like three different parent functions, and you cut the parent functions into pieces and piece them together to make a new, here you go, there it is, right? So you got 3 different parent functions, and you cut them into pieces, but you piece the 3 together down here to make the new final graph. And how do you decide where to cut the pieces? The where, right? The where column tells you, quote, where to cut. This one says, from -infinity up to -1, use the first graph. Between -1 and +1, use the middle graph. And between 1 and infinity, use the third graph. And that's how we get the final graph that's over here. Piecewise functions are not that tough of a thing. They're just like a new language to you guys. You haven't seen them before. But that's how we would have graphed that one there. If you take a look at the one that was on that problem, it had like a quadratic and a linear, and it was going to be a little bit of work. But don't worry about doing that free response. We're going to just move on to the next section starting tomorrow. Now, I should be able to give you guys a quiz on this week. If we look at the things that we've done so far, all things on Friday. All things related to transformations, right?
So
All things
basics.
related to parent functions, all the things we did on that first homework. If I give you an equation and I ask you to tell me the transformations, graph it for me, what's the parent function, what's the coordinate now, that's the new thing we added, the x, y becomes blah, 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 right? I should be able to give you a quiz on that. And then any of these f of x. I might take that same function that I asked you, and I might say, okay, give me these points. What's f of 3? What's f of 2? F of blank equals 5. And I should be able to get any of those back from you.
Well, we also use it for checking
I don't have a problem with that.
Will it help us?
I mean, you'll need to know the parent functions. It's important for you guys to know the parent functions. If we were in pre-cal, the answer would be no, but for now, yeah. Yes.
Are there gonna be stretches and strengths?
Probably. I mean, there'll be some basic. I mean, I don't know. Look at the problems that are in the book. They didn't have any so far that were stretches, right?
So
If it was, it would be just by 2. I would never put like by 5 just because it's easy to graph. It'd be like by 2 or something.
it will all just be from what we started on Monday.
And I mean, last week's stuff is really a carryover into this week. It's really the same stuff, just kind of a different format.
Will you make a study guide for us, or will we just study out of this?
I have 2 versions of each test. I could probably give you guys out one.
Doesn't that mean you can't retake it? Like you did the other one?
It's a good question. I have both of them. We have a couple of vandals in the class. Austin, can we come over here?
Is there a vandal?
It's the one thing that we always ask.
Yeah,
And see, it got cold again, right? It got hot halfway through class.
What the heck?
It's like, I might have to get a fan to just circulate the air in here. I really wish it was all stay off. I'd be fine if the air conditioner was both off. I don't want it hot, I don't want it cold, I just want it to.
Yeah, I just give
Why is the air conditioning so messed up?
Well, here's the reason. The rooms are linked together in groups, and we don't know how they're linked. So if one person's turning theirs up, then it's affecting other classrooms, and then they're turning theirs down. Because they share an air conditioner, right? The machine itself is running, and it runs for like 3 rooms.
How do you not know?
We don't know which rooms are connected,
Oh my
so it's
God.
like a puzzle. We're like, okay, these rooms are cold right now. Those are all 3 probably connected. So that's what we need is we need like a vlog, and we all need to report when our rooms are cold.
Yeah. And I'm like, hey, can we get a blueprint
Oh,
of the
so-
air conditioning?
It's the unused rooms are heated. Heating rooms. Yeah, I already finished my math. Mysterium rooms. Are there any references from Hogwarts that we can call those empty rooms? Because this place still looks like Hogwarts. What? What? The room of requirements. What is that? It's where you need a room to do something, and it becomes that room. So, like, you need to use the bathroom. It becomes the bathroom. You need a place that you can practice dueling. It becomes a dueling classroom.
What is Quidditch sport? Would you wait?
If you need a
Then a
room to
lot of
practice
people would
Quidditch,
die.
it becomes a
A lot of
Quidditch
people
practice room.
Think of it though. A lot of people would die if Quidditch was a real sport.
Why?
Because
I've seen
there's
so
so
many
many more
deaths and
accidents.
injuries.
If you
It's
fall
just
off,
soccer.
if you fall off your broom, you die.
It's just the
It's soccer, but if you trip, you die.
it's just the Norwegian soccer.
It's insanely complicated soccer.
It's Norwegian soccer.
Except you die all the time.
Dang.
Yeah. What if the bludger hits you in the face? You'll die.
Yes, it's just Sherlock Holmes, put it in the front of the face, in the front of the head. You have no idea.
Yeah, you don't know. No, like you don't know.
You guys gonna
Oscom Valley
yesterday
except front on the head
you
instead
guys gonna show for
back
robotics?
left.
Yeah.
Yeah. Okay, that's good.
And I'm doing it.
Hello.
Hey, we
You
should
just
not.
left this.
I did.
All right, groups of no more than 2, please.
Wait, I thought we were gonna do the thing where it's like, where are we to?
Yes, I'm gonna have you guys in sides of the room because you're working close. But I don't want you guys in groups of more than 2 because we have way too much chattiness in all of the tutoring. So let's do this. Thiessen on this side of the room. And we will do Vinay. Let's see, Kalyankar towards the back and Conaway up here. I think I have the least. So Thiessen will be that side of the room. Let's do that side. Let's wait until we see how many we have, but that's roughly it.
I gotta get me a book. I'm gonna go get a book.
Simon,
Hey.
how's it going?
You heard it.
Yeah. Good.
Are you the only one here?
Okay.
No, there's
I'm not sure. But my mom was just like, you need to take a test.